An object is projected from a height 80 meter above the ground with a velocity of 40 meter per second at an angle of 30 degrees with the horizontal. What is the landing velocity of the object? Now, the first thing we have to do, don't forget, we try to interpret this using the diagram. Let's see how we can interpret that. An object is projected from a height 80 meter above the ground with a velocity of 40 meter per second at an angle of this. This is the initial speed. Initial velocity is 40 meter per second. The angle of projection is 30 degrees with the horizontal. Now, this was done from the top of an elevated surface. Now, it could be on the top of a building, it could be any elevated surface. So let's say it's a building actually. Let's assume that it's projected from the top of a building. Somebody stands here and projects an object from the top of a building like this. It throws it up against the horizontal like this. This was done at an angle of 30 degrees. So what do we have? We have a projection that goes this way. The object gets to max height, then falls down like this. So what are we asked to get? We are asked to get the landing velocity of the object. Now don't forget that for us to get landing velocity, we will need two major components of velocities. We need the final velocity along the x-axis and the final velocity along the y-axis. Don't forget that the final velocity along the x-axis is the same thing as the final velocity, as the initial velocity along the x-axis, because there is no acceleration on the ground. That's the reason. We've seen a couple of that in our previous lessons on projectile. So what we're going to do first is this. Don't forget what we have here is trajectory. We are looking at the path of flight. We are not talking about max height, so we are not really talking about range and the other ones that we derive different formulas for. So the first thing we're going to do, first of all, we know that this very object was projected from a height of 80 meter, the height of this building. It could be a building, it could be anything. I only assume that there's a building. This 80 meter, that's the height. Now this stuff was projected. Now for the fact that it was projected, it's going to get to another height. It will attain the max height. Now the max height will be added to this height that we have already. We already have an height. We already have a height. I beg your pardon. We have a height of 80 meter. So this stuff was shot into the air, went into flight. Now it's going to get to max height. Now from max height, they start dropping back to this place. So let's see. Let's get the max height first. That's the first thing. Let's get the max height. It will contribute to the distance along the y-axis. So what's the formula for max height? The formula for max height, quickly, let's get that. For max height, h max, don't forget, that formula was derived from v squared equal to u squared plus 2as. At max height, final velocity is 0. So the u sign this along y-axis, don't forget. So this u